Awesome. Well, thanks everyone for joining. Great to have you here. This is a webinar put on by the team here at Diagrid. My name is Alice Gibbons. I'm head of our customer success engineering team here at Diagrid. And today we are going to be talking to you about 10 methods for improving your Dapr operations using our SaaS tool called Diagrid Conductor. And we're going to give you some tips and tricks essentially for, running Dapr in production, as well as things you can do, when you have like a number of clusters, when you have a single cluster, kind of the full gambit of recommendations there. Bogan, do you want to introduce yourself?
Yeah, quickly. My name is Bilgini Briam, and I'm the product manager at Diagrid, and I'll be also sharing with you some tips and tricks we learned from our customers.
Yeah, awesome. Yeah, so, as Bilgin mentioned, we get to work with a ton of different Dapr users every single day. If you haven't kind of come across us in the Diagrid sphere before, our mission right here is to boost developer productivity by providing tools and APIs for building and operating cloud-native applications. It's founded by these two smiling gentlemen on the right here. And, we're big in the cloud-native computing space. Dapr is I think it's still like the 14th largest project in the CNCF and has a really big dev community around it. So, really our bread and butter is building distributed applications, and we get to work with, a number of users doing this every single day. So specifically what just once on our production or what we are offering before we get into kind of the recommendations, specifically Diagrid is focused around, all things Dapr for the enterprise. We really work with a ton of different enterprises who are running Dapr for their mission critical applications. And, things like offering our, open source 24/7 production support where, we have response times and SLAs that are as low as 1 hour. As well as we have a custom distribution. This was released earlier this year. It's called Diagrid Dapr Distribution for Enterprise, bit of a mouthful, but it has a number of features that we specifically worked with some banking customers in order to kind of get what they needed and what they desired for running Dapr in multi-tenant environments. A number of other things. I won't drain this entire slide, but we'll talk a lot about Conductor today, which helps you automate Dapr on Kubernetes. So essentially manages the Dapr control plane, and it controls a lot of the operational tasks that you would have to do to keep your Dapr environment up and running. And then we also provide, a number of things like architectural reviews and training, CVE resolution for, the open source project, things like that. And then I guess I should have said, if anyone has any questions, this is a new webinar platform for us, but toss them in the chat. I think that, we will both be monitoring the chat kind of as we go, but, feel free to put them in there, and we can also get to some questions at the end. And then with that, kind of the stuff we're going to cover today is all really about, Dapr operations in production. So we, as mentioned, we work with a ton of different Dapr users. We kind of have been able to streamline and group these categories into kind of 4 different areas. So, when you are running, like I said, a number of clusters or just a couple, we want to be able to have, these kind of four tenets of being able to monitor and troubleshoot failures. Of course, that is, every operations team bread and butter, number one thing that they are focusing on. Enforcing resiliency across applications and infrastructure. This is, of course, critical for any distributed application, ensuring that, of course, the network is non-reliable there, and baking in these resiliency policies for both apps and infra are key. And then also getting down to really productionalizing the Dapr control plane. So, Dapr itself has a control plane which does a number of things to keep your applications up and running, whether that is, for service-to-service indication, for pub sub APIs. There's a few of these key services that, need to provide best practices for. And then last but not least, streamlining versions and deployment. So, ensuring that your versions are kept up to date, ensuring that the deployment methodologies that you're using, whether that be like a GitOps method or, putting them in source control, ensuring those are all following kind of best practices there. So that's kind of what we're going to talk about. I'm going to kick it off. The first recommendation here is really just ensuring that you're able to catch infrastructure downtime quickly. So of course, we have alerts, metrics, and logs. These are all things that you would want to be monitoring and looking for, when you are running Dapr systems. We one benefit of Dapr, I would say, over, if you're using some of the monitoring or alerts on like maybe a service mesh, is that you actually get this infrastructure integration kind of built into your platform. So, I can get metrics alerts, or I can get, these metrics that are specifically based on my underlying infrastructure without having to go into my infrastructure services and combine those monitoring systems into my own. So I'll kind of do a demo of this in a second, but being able to, see what's actually happening with your underlying infrastructure, but on the application plane is really powerful. We also have, because Dapr offers the APIs in both gRPC and HTTP, there's really good metrics for both of those protocols. And then, excuse me, there's a number of, observability things you can look at within the logging. So things like component initialization failures, which again will, bubble up those infrastructure failures to your application infra. Specifically, would be amiss to talk about like alerts and observability without bringing up tracing. So Dapr offers, tracing out of the box, which is specifically like through all of, again, your applications and your infrastructure. It works really well with both Zipkin and OpenTelemetry protocols, and you can kind of send that to whatever different monitoring backend that you are using. We see a ton of people using, like, of course, OpenTelemetry Collector these days, very popular. And then also what we do from a conductor perspective here is actually build out these kind of dynamic application graphs using golden metrics such as error rate, RPS latency, and then being able to just use the metrics from your applications and infra and kind of populate the different application calls in near real time, which again allows you to like pinpoint these issues and pinpoint kind of what exactly is going on within your application. And then one thing that was super critical that was released, I believe in Dapr 115, was the ability to monitor the error codes. So specifically, error codes, if you're unfamiliar with them, allow you to have these standardized strings for, this says here over 80, but it's actually over 100 now, 100 different common errors across both HTTP and gRPC. And they are returned in the JSON body of any of the requests that you make to the Dapr sidecar, or some of the control plane as well. They are typically logged in debug level logs from the Dapr perspective. But if you don't really want to keep all your applications in debug log, what you can do is use what are called the Dapr error code metrics. And so this essentially allows you, as you can see on this little graph on the right here, to see like what errors are going on without enabling debug logs and just by using kind of the metrics. So I can see that there is a service invocation error that's kind of happening just by enabling these metrics and kind of when that has been going on. So those are some of the best practices around monitoring. And with that, I wanted to flip over into Conductor now. I think you should be able to see my screen here. And then, just talk a little bit about kind of what this looks like from a monitoring perspective. So here I am in the Conductor portal. This is a portal where you can add whatever kind of Kubernetes cluster that is running Dapr that you want, whether that is running locally, whether that is running on your favorite cloud provider, whether that is running, on-prem. There's a number of things, and I'll go over some of the deployment methods later, but specifically today we want to talk about monitoring. So if I look at a cluster that I already have, this one is on GKE, but I can see that I have a number of insights specifically around cluster level, around the application level, and then bringing down to components. So that's the infrastructure abstraction that Dapr gives you. There are a number of ways to kind of get into the, seeing what's going on in my cluster. I'm going to start actually from the component side today. So components, again, are that abstraction between your apps and your infra. And I just want to show you how we can find a component failure really quickly with Conductor. So you can see from looking at this graph, I can see all the different components that are loaded within my cluster. These are all YAML specifications of the infrastructure connections. And specifically, you can kind of see here, I have this Kafka one. This is a message broker that I'm using within my distributed app to do like a publish subscribe pattern between my two services. And you can see I have a number of the kind of details about this. And I can also see that this has been initialized, meaning that, the application that is calling out to this can actually reach out to this connection details. So, you can actually see the fact that, this is checked, and you can actually see like hey, my app is currently able to connect to this based on a check that we are running from the conductor side. And based on that, I'm going to just scale this down to 0 replicas. So essentially I have Kafka just deployed on the same cluster in this case, and you can kind of see that this is going to be, just wait on there, just gonna take a sec, but I had 3 replicas up there, and now I'm just scaling that down to 0 to simulate, okay, my Kafka broker went down. Now how does this show up from a conductor perspective? So if I head back over, while those pods are kind of scaling down here, I just want to talk a little bit about what else you kind of see from a component perspective. So as I mentioned, you can see all of the different infrastructure connection details. So things like the password, things like the message broker, things like that. And I can actually also get the subscriptions that are specific to this. And you can see actually the init failure just happened, but I'm just going to finish this quickly. So we have a number of subscriptions that are automatically created via the declarative route. So essentially this is when you're using your just subscription, your pub sub pattern within code. And you can actually see that kind of popping up here. You can see if there's routes that are set, dead letter topics, things like that. Similarly, or sorry, that was declarative. So those are ones that are created within YAML. And I can actually view the YAML as well. But then if I look at the programmatic one, these are the ones that are also directly created in code. So, whatever SDK that I'm using, I believe in this case, it's a .NET SDK, I would set up my subscription with, the topic or the pub sub name I want to subscribe to, and the route that I want to, route these messages to from the message broker. And this is something that I'm going to be able to kind of give visibility to from a conductor perspective. And as I said, right, so I brought down that component. You can see I brought down that message broker. You can see that I already got that infra error. So it's telling me, hey, I can't reach out to this Kafka broker anymore. This is a problem. And this is kind of telling me it's initialization timeout. And again, init is a function from a Dapr side that will always get called initially on startup within Dapr D. But then, what we are doing from a conductor side is continuously calling that every minute. So one other way we can kind of see this is by coming into the applications that it's used by. So, my order service in this case is a publisher for this app. And this is going to bring me into kind of the first view I have into my application that is using this message broker. So I can see, the Dapr application ID, I can see the pod status, the components that it's being used, also a number of these insights, which are going to be really important. I can also see things like, the configuration. So this is specific to any sort of configuration options you want to enable from the Dapr side. So like I can look at these, metrics are enabled, record error codes are true, which is actually something that we need in order to see which errors are going to be loaded for this application or which errors are going to be triggered. Back there. And then, I can see a number of these other metrics that are automatically pulled. So by default, Dapr comes with over 150 metrics out of the box, and it can be really difficult to choose which ones you want to make alerts or kind of which ones you actually want to view within your monitoring tools. And so what we're doing from a conductor perspective here is actually creating these graphs for you, so you can kind of look at the memory and CPU usage over time. Of course, this is going to be broken out by app and Dapr D. And in Kubernetes, in this case, Dapr is running as a sidecar pattern. So you're going to have that kind of 1-to-1 of ratio of applications to Dapr sidecars. Additionally, I also have a number of, the requests, both the latency of HTTP and gRPC. So, if I want to take a peek at what has been going on from a latency perspective, that's totally something I can do. These are all viewable over, of course, different time spans. And then also, from a gRPC perspective. So, here we have our gRPC one, and this is also getting really high latency. So that makes sense because I just took that Kafka broker down, right? So that's kind of the first instance of that kind of trickling in. And then requests per second, and then of course the error rate. So RPS, you can kind of see this one is kind of trickling up here, and that's the publish event, while this other one is kind of going down. So this was, we're not getting that okay status from the publisher anymore. And now if I kind of head to the top, you can see like everything's kind of turned red. So, not only do I have that component initialization that I already talked about, but there also are these critical metrics alerts. And this is going to bring me to exactly like what is kind of going wrong within my application. And I can see, this one that kind of showed up here. So it just fired. Yeah, so 5:17 p.m., which is just for me. And this is, it's saying, hey, your application to Dapr gRPC error rate has been more than 30% for around 2 minutes. So this is specific to, reaching out from your app to Dapr or to that Dapr sidecar using gRPC. And this is because, kind of as I was showing before, right, we are, in this case, this application is using the .NET SDK, which is using gRPC by default to call out to the Dapr sidecar. So that's, if I go head back to that metrics alert that I was just talking about, and then now you also see there's also the component error rate. So again, this is very specific to the infrastructure component, so that Kafka message broker. I head into that source metric, I'm also going to get a number of these component graphs, this component metric graphs. And this is like definitely a huge benefit of the monitoring that you're able to get with Dapr, because again, like this would be difficult to discern if you weren't using infrastructure specific graphics, right? So, or infrastructure specific metrics, sorry. So I can kind of see, hey, this component error rate that's just started to fail is, egress from the topic orders, and this is the specific this is the specific component for that Kafka pub sub. So it's called oms.pubsub, which again, if I pop up here, I'm getting that init status error, obviously, as I talked about. But then, this one is the name of that corresponding to the underlying message broker. So again, now everything's kind of lighting up like a bit of a Christmas tree here. And of course, the latency will also be super high. So again, just like these golden metrics for from a component perspective, from an application perspective, being able to kind of track these issues across the board. And then the last thing I wanted to show was specifically, sorry, I was here. If I go back to metrics alert, was on this errors overview tab. So this is like the holistic view of any of the errors that are going on within your application. We're actually not seeing anything from an HTTP perspective. That's fine. That's kind of normal. Again, we're using the SDK within our application. Makes sense. That gRPC error rate, I talked about that, right? That is something that, is going to trigger pretty much right away because obviously it cannot reach out to Kafka. And then the error code. So this is where we're going to be able to diagnose the issue a little bit further. So it's telling me, hey, error pubsub publish message, pubsub, lots of pubsubs in there. But this is specific to saying, hey, we absolutely cannot publish this message. And this is coming directly from that Dapr error codes metric, which is definitely something that you should enable if you're running Dapr in production. I guess the last thing I just wanted to show. So I was looking in there based on the metrics and based on that component initialization. But one thing I didn't talk about is if you want a more kind of holistic view of your full system, you can use what's called the application graph. And this is going to show me not only, how my applications are connected, but it's also going to give me a view into some of those metrics I was looking at already, but more from a 10,000 foot level. So I can see not only, hey, these are how my applications are communicating from a synchronous perspective as well as async. So the dotted line here is denoting like a message broker, whereas that solid line is synchronous service to service invocation. But if I take a peek at any of these red ones, so I can like go in and just look at all these unhealthy apps, it's going to tell me, okay, both of these have alerts that are firing. Those alerts are specific to some of those error metrics that we saw earlier. And then I can actually get a more holistic look into, okay, so, this virtual customer, which is like a load simulator, is calling out to my order service, which, as I mentioned, is my publisher app. And the order service itself is saying that it's healthy. But if I take a peek, the calls to the message broker here are failing at like 100%. Which makes sense. It's down. I can also isolate on the infrastructure itself. Actually, I'm going to click on healthy as well. And this is going to show me a full dependency graph on like any other applications that might be affected based on this infrastructure failure. So, if I want to let's just close this one. I go back into specifically this one. So it's telling me, hey, so far it's just this order processor workflow that's still up and healthy, but there's no new requests that are coming out from that message broker. And it is also showing the latency here. So anytime you have a latency that's higher, I think than like 10 seconds, or maybe it's a few seconds, it's going to show up in yellow. And then you can also, of course, see kind of the average of these calls over the past, in this case, it is 1 hour. And then the other thing that we're enabling is, again, just a different view into each of these guys. So, as I said, we are looking at the message broker right now. And if you wanted to take a peek at like all of the incoming calls to this, we have the latency from this perspective. You can also look at that throughput, or of course that error rate. So this is showing me the error rate from this. Another way to kind of get a peek into kind of what's going on this surface. And then of course I can kind of jump in if I wanted to and head back to the system and see, hey, the components failed, or jump into that application if I want to and check out those specific errors as I was looking at before. So just different paths kind of to the same resolution. And with that was kind of just what I wanted to show from an error monitoring perspective. If I hand it over to Bilgin.
Cool.
Recommendations.
Thanks, Alice. This is very representative of failure scenario with the infrastructure going down. I want to continue this with how you can make your applications more resilient. And the way to do that with Dapr is making use of the resiliency policies. As you know, Dapr has timeouts, retries, circuit breakers. And I want to show how you can apply those. Also mention that one of the new cool features that was added in the latest Dapr release 1.15 is, for example, ability to perform retries based on specific error codes. Right? Before 1.15, retries would always apply, which is not very practical. Right? In 1.15, you can decide which error codes you want to retry on. And Dapr documentation actually has some guidelines which error codes you may be good candidates for retrying and which are not. Of course, that's also dependent on your business logic. You have to pick operations that are important and safe from the business point of view. While Dapr resiliency policy is powerful, configuring those can be a bit daunting. And I want to show how. So from what Alice was showing you, once you go in Conductor on the left-hand side, on the top we have operations around the cluster, and then further down, operations that are grouped under develop. While this says develop, because here you are creating various Dapr resources, YAML files. They're primarily useful development, but you might need them also in other environments. For example, as a member of the operations team, you may have to configure, a state store that is different than what developers using locally or Kubernetes. You may have to create one for your cloud environment. So the component builder, for example, can be useful in that scenario. But what I'm going to show you now is the resiliency builder and how to create a resiliency policy. The first thing you have to do is just to name your resiliency policy. I'll just call it demo for the sake of the demo. Here you have the option to select clusters, and the main thing this will help you is it will bring some context from the cluster so that you can easily scope this policy to various applications, and later easily you can find different components, actors from that cluster. That's the only reason. The first thing we will have to do here is decide what kind of policies you want to create. For example, if you want to apply a timeout policy so that the application can detect failures faster, okay? The only thing we have to add here is the duration. Now, good way to come up with the number here would be, for example, looking into the graphs Alice was showing you and find out what is the latency when talking to Kafka, for example, if they're going to apply a retry policy when interacting with Kafka, and give a bit headroom and pick a number. Right here, something that Dapr resiliency policy doesn't like. Our guided wizard will help. This is not a valid value, right? So you can fix it while you're typing it. I'll keep the default value of 30 seconds. While timeout is the easiest one, other policies can be a bit more involved. For example, with the retries, you have actually option to see the built-in retries that always ship in Dapr. And in addition to seeing them, if you keep the name of the built-in retry, you have the opportunity to override that. That's one thing. But in this case, I'm not going to override the default one. I'll just call this retry one as it was before. And you can see, depending on your selections here, the form is dynamic because this is what the Dapr YAML file expects. So different fields appear, and this form will guide you. So depending on the retry policy, you can set different values. Here I'll keep it constant to retry 3 times, with 5-second delays. And here are the new status code-based filtering that was added in 1.15. It says this applies only from Dapr 1.15, and it also shows you what's the right syntax, how you can select those, right? For example, you can pick 500. If you're using gRPC, you select the gRPC, and so forth. Similarly, we can create a circuit breaker. The interesting thing with the circuit breaker is, say that you can actually use common expressions to decide when to trip the circuit breaker. And one thing we've done here is we have actually quite a helpful menu here. You can know which keywords you can use. You can make the circuit breaker trip based on number of requests, number of successful requests. I'm not sure how that can be useful, but it is available. I think the most popular two options are the number of total failure or consecutive failure, right? The default is, if the request is failing consecutively over 5 times, or open up the circuit breaker for 60 seconds and then try 1 time to see if the resource has recovered or not. So I'll keep that, and then we can scope these policies to different applications or components. So if I go to the components tab, you can see these are all the components from the cluster because we scoped to the cluster. And since Alice brought down Kafka, I think it was Kafka, right? The message broker, I'll select that, and I'm selecting the direction which is when I'm interacting with Kafka, publishing to Kafka, and I can apply all these policies, right? And with that, I get to the final screen, which gives me the YAML file with the right structure, values, etc. At this point, I have the option to download this or copy to my IDE, check in to source control system. There is no way to apply this directly, right? Because we think that's not the right way to do changes to your cluster. But you can get the file from here, download it, and do apply. Now we already applied the policy in the cluster as was showing, so I'll quickly go to that. If I go to the resiliency tab, I can see there is a resiliency policy. I can see which applications it's scoped to. So I can go to order service, for example, and there I can see its policy. We can see this policy. It is more info than the one we've created. I don't think we need all of this, but it basically does a similar thing. It applies a retry. So if we start with retry, it applies a retry policy. It's basically retrying up to 30 times with 5-second delay. That's a straightforward retry policy. Then it has a timeout policy, which is called general. So attempts will time out in 5 seconds, and there is also a circuit breaker. right? A circuit breaker that trips at 60 seconds after 3 consecutive failures. One thing you can see here is now I have visibility into the behavior of the resiliency policy. And here, for example, I can see that once the broker went down, I think the first thing that happens is the number of timeouts went up, and then they went down. And the reason for that is we can see that the retries kicked in after the connection was timing out and the circuit breaker, right? If I further scroll down, I can now see the status of the circuit breaker. In Dapr 1.15, again, there was, I think, new metrics added that actually can show us the status of the circuit breaker. And here we can see before the broker went down, it was closed and working fine. Then the circuit breaker tripped and it stopped passing the request to the broker. And every now and then, every 16 seconds, it is trying to connect, but it's still failing. And the circuit breaker is remaining in open state, right? So this gives you visibility in to behavior of the resiliency policy. Now, if this happens at the time when you are not in conductor, right, you don't have to come here and see. Actually, we have alerts that are for this. So if I go to the notification view and search here for resiliency, you can see that there are alerts firing that are saying, application resiliency policy retry rate is firing, and I can see it's firing from the order service, and I can go back there and see what's going on. These alerts can be in conductor or can be delivered to you by email or other ways. So with that, if I go to slide quickly what we've done, basically a resiliency policy, we can apply that to cluster. Then we can get, we can observe how that policy is behaving, whether it's behaving the way we want, or we have to adjust some of the values. And if needed, we can get, notifications. And I think it's a cycle based on your observation. Most likely, you may have to adjust some values to get the while the system is evolving and the load is changing. And here, quickly to mention, actually a good book on this topic is this book by Sam Newman, which goes into building resilient applications, what error codes are, for example, good for retrying, which are not. So check that out. That I want to continue to one, we can make your apps production ready. And that's about recurring tasks. Almost any distributed system has recurring tasks, whether that is, to performing some kind of a backup at night, sending emails, poking a service to do this. And in Dapr, there are different ways to do that, multiple ways. Here I have only two to show you. For example, the traditional way of scheduling task was through cron binding, right? Which is very simple way of telling Dapr, with a single YAML file to schedule cron tasks to call your application. And if you look at how it performs, what are its characteristics? Cron bind is in memory, right? It's not persistent. Its reliability, I would say by default, is short. Because it's in memory, and if you restart at that time, it may miss to trigger and nothing will happen, right? It's not really scalable in a sense. If you scale the number of instances, all the sidecars will start getting, triggers, and typically that's not what you want. And it only supports, HTTP with no ability to specify any kind of custom payload to give to the application. So it's quite limited. In Dapr 1.14 and I think in 15, what we got is the Jobs API, which is the more reliable, durable way of scheduling tasks. Which the Jobs API is backed by a scheduler service, which we'll see in a second, which is storing the schedules in etcd in a reliable way. It is more reliable because it will perform, at least once delivery to your app. So it will make sure if you don't miss any schedules. It is highly available and scalable by design, and supports gRPC, HTTP, and ability to give to specify custom payload. So you can tell to the application what to do. Now, these are only 2 ways to do recurring tasks. Then, if you are using, actors, there are 2 other ways: actor timers and reminders. One of them is in memory, and the other one is also persistent. If you are using workflows also have timers and duration, right? And there's the jobs API. And if you look here, the actor, reminder, workflow, timer, and jobs API, they are all behind the scene with Dapr 115. They're using the scheduler service, which is one of the Dapr control plane components. So while the developer may choose to use these different, bindings, APIs, Dapr capabilities, as operational person, it's kind of your responsibility to make sure the scheduler service is properly tuned and looked after, because it may in fact multiple Dapr APIs and apps. So to do that, here's a short list of things you can do to make the scheduler service more reliable. We'll go through this and see how Conductor helps you to do all of this. Basically, you have to make sure that it is highly available, enough sufficient resources, it's not evicted, has enough storage and alerts in place. So let's see that. So the way I'll do that is go again to our cluster, right? I'll go to our cluster, to the advisor tab, where we can see different recommendations for this cluster. I want to see all recommendations, but we don't have time to go through all of these, so that's why we'll pick the ones that are specifically around the scheduler. And the first one we said is you need to do the scheduler highly available. Actually, it's recommended to make the whole Dapr control plane highly available. And here the advisor will tell you what you have in order to do that. And if you make the whole control plane highly available, the scheduler will be highly available as well. Actually, if you deploy the scheduler on Kubernetes with 115, it becomes highly available. But this is a must-have setting in production environments. And in Conductor, actually, I can apply this, press this, and fix it straight away in Conductor if that's what you want. Quickly going through this list in interest of time, the next thing we said was make sure it has sufficient resources. And that is true for the new scheduler service, but actually it's true also for all the control plane components. Here, the advisor will give you, some good starting points, good values to start with. But in reality, what you have to do is, for the scheduler, you have to look at its usage. So one way you can do that is in Conductor of this cluster, I can go to the control plane and I can see all the control plane components, what's the CPU and memory usage, right? I can see that for, past time. And from here, I can have an idea what's a good value to set for each of these control plane components. Just pay attention for the scheduler one, because it's quite sensitive on the based on the number of workloads or what you store in these timers, actors, etc. Now, continuing with the list here, the next one we said is making sure your application is not running as root. So if I go again here and search for root. Okay. Where are you? Yeah, we have a long list. I think it's like non-root. Did I filter by anything? No. Okay. We need to add a search field here. No, this is okay. I cannot find that one, but if I find, I'll come back to it later. But basically, what it comes down to is there is a Helm value that makes sure that all control plane components are running as non-root. And if you set that, that will make sure that none of the processes can be, accidentally or maliciously upgraded to a root user. That is a Kubernetes setting that helps you to protect from that. And right now,
if you filter by,
just found it. Okay. Yeah, basically, yeah, this is the setting, and it's it applies to all control plane components, and it's a good idea to set that in production. Now, for each of these advisors, we also give you links directly to Dapr documentation where you can see further details if you want. So once you make sure that your control plane is HA, it's running, it has sufficient resources running as non-root. Next thing is make sure that it's not evicted. Now, if we can find the eviction advisor, I think I can just search for things. That's the problem is my search has given up on this dynamic table. Okay. No, I'll have to scroll down. Apologies, everyone.
Playing Chrome.
Yeah, here. The idea of this advisor is that there can be times when your node, where the control plane is running, may get some resource pressure, whether that's for CPU and memory. And by setting this property, you can mark the control plane resources basically with higher priority, so that they will be the last one to be evicted. And they won't be evicted before other resources on that node, right? So again, a good idea to set this for the whole control plane, including the scheduler. And last category here is around storage, because the scheduler service is using etcd, embedded etcd. It needs a storage that will be stored on the volumes. The default storage is 1 gigabyte, which is most likely won't be enough for you in production. So a good idea is to set that to check your usage and double that. But a good starting point would be probably good to go with the 16 gigabytes. And here again, the link provides information how you can expand that from 1 to 16. If you've already started with 1, it might be possible with some storage providers. With that, I think your scheduler probably is in a good place. And if something goes wrong, we also have alerts. So if you go to notifications rows, for example, I can search here for scheduler. See, by default, we ship a number of alerts for the whole control plane applications. The scheduler is also monitored by default, and you'll get a notification if it's not available. But you also can set custom alerts. Here, for example, I set a custom alert for the scheduler to get notified if the memory usage goes above 2 gigabytes, for example. Right. And with that is the list. You can apply all of these by checking the Dapr documentation, but the advantage of Conductor is Conductor will continuously analyze your cluster and will send you emails if anything goes wrong. And these best practices, they may change with different versions of Dapr. So conductor will make sure it's continuously monitored. With that, I want to pass to Alice for the next section.
Awesome. Yeah, and just like, to kind of finish that up, the scheduler is like something we talk about a lot with customers, like especially with, 115 being have a little bit more operational overhead. It's definitely something that, comes into play much more. It's another stateful set. There is, some concerns, not concerns, some considerations with it rather, in terms of if you're an actors user, if you are a jobs API user, or, if you are using workflow as well. So just really wanted to underscore that point that these are super critical because we have had issues in production. Awesome. Yeah. So kind of, finishing up some of the best practices here, like we, one of the things we talk about a lot is like the way that you deploy Dapr and the way that you're kind of managing the versions as well as the clusters and the configuration across all of those. So, one thing that I have mentioned already is specific, like you can create these cluster connections from a conductor perspective and install them, whether that is on any of the clouds, AWS, EKS, AKS, GKE, on Edge, any really CNCF Kubernetes cluster is supported here, as well as like local development. So we have a ton of different like local development options. If you are running Kind or Minikube locally and then you have Dapr installed, it's super easy to just kind of connect your cluster and like get up and running as like the quickest way to install Dapr on there, because there is some best practices kind of built in. One of the things we did recently was support kind of for GitOps and the ability to, take the Helm charts for both Dapr and Conductor and actually, embed them specifically into like Argo, CD, or even Flux, of course, still works if you are a Flux user, but just the configuration of, both the Dapr Helm chart as well as providing Conductor as a Helm chart is actually still able to manage that separate Helm chart within your cluster while still, maintaining the best practices and things that we've talked about already. So I'm going to flip over and show that.
Just showing off the new Helm-backed cluster connection experience. If I am in the Conductor UI, I can see that these are all my clusters, again, that I have connected using a cluster connection to my dashboard. I can add a new cluster connection, again, the same way as I typically would going before. So, I can use the UI, I can use the CLI to do this. Here I am in the user interface, of course. And then I'm going to choose a unique name. I'm just going to call it Helm Test for now. And then I'm going to choose the Kubernetes distribution that describes my cluster. So we are testing, of course, on all of the main cloud providers as well as OpenShift. But then any sort of CNCF supported distribution of Kubernetes should be supported. So here I'm going to choose other because I have a Kind cluster running on my local machine. I'm going to choose non-production because that is the type of my cluster. And then here is where, I click that Helm Manage button. And this essentially tells Conductor that the configuration for Dapr and the configuration for the cluster connection are managed by Helm instead of, the Conductor UI or the Conductor CLI. So this will allow the configuration and the management to be taken away from the control plane. And then it's really good if you have, scenarios like Argo CD or other GitOps, and you want to store that configuration into your Git repo and kind of run it from there and manage it that way. Of course, then I can choose whether to install Dapr or not. This will install Dapr as a separate Helm chart via Conductor. And then, of course, you can manage that, like I said, through your configuration option that you choose. I'm going to choose the version. This is, again, pretty normal if you were creating a regular cluster connection, if you will. There's release candidate versions that we get into Conductor as well. But then there is all the options for supported versions of Dapr, including the most recent version and then the two previous minor versions. I'm going to choose the namespace to deploy Dapr into, and then we have some of these kind of Helm arguments profiles, and these are best practice recommendations of essentially how to configure your Kubernetes Dapr control plane. So you can see I have some priority classes in here, I have highly available enabled, things like that, and then I'm going to click create. And this is going to give me two Helm commands. It's going to give me one to install the cluster connection and the other one to install Dapr. So essentially, if I want to run that on a cluster, I'm going to flip over to my cluster here. You can see it's pretty bare right now. I don't have a ton of stuff installed on it. And again, this is just a Kind cluster running locally. So the first thing I'm going to do is run my, cluster connection Helm chart installation command, and that one is going to kind of run it there. It looks good, and you can kind of see in a second here, it's going to give me that Diagrid Cloud namespace, and it's going to install that into there. Similarly, if I can choose my Dapr installation command, I'm also going to run that Dapr install command. Again, I'm using 15.4. This is all the open source versions of Dapr and all that greatness. And then that is going to run to completion. If I want to check out the Helm values, I can also download those guys. Again, I can totally edit them if I want to. I'm going to pop these open so you can see. This one is the, these are the Helm values for the cluster connection. So I can see, all of the different connection strings, the keys, things like that. And then if I head back to the UI here and download the Dapr ones as well, and then pop that open, I have all the different Dapr ones that I have installed. So I can see, again, these are the ones I configured using that UI in the previous screen. And then if I come back to my cluster, you can see this was installed. And then if I go back into look at the namespaces now, I can see, okay, those are kind of coming up and running in that Dapr system namespace. And then if I click done from this perspective, this all looks good from here. So again, installing 15.4, I have the control plane looking healthy, all those things. And yeah, this is pretty much the Helm installation experience. As I mentioned, this will put Conductor into kind of read-only mode from an upgrade perspective. You're not going to be able to edit the cluster connection because that is managed by Helm. And then you're also not going to be able to edit or upgrade Dapr because that is also managed by Helm. So this is something, again, you'd want to do specifically if you are choosing to go down Helm as your kind of configuration management solution on Kubernetes.
And so, yeah, kind of just the final call out for today. Like if you are running Dapr, whether that be, on a number of clusters or just like one or two, we'd highly recommend to try out just a free trial of Conductor. You can scan this QR code. You can check out the Diagrid.io website. There's a number of things that you get with a 30-day free trial, including all of the different advisories that Bilgan talked about, specifically for Scheduler, but then also, the other control plane and application components. After 30 days, it does automatically go down to a free plan, but you kind of get the experience of trying out any of the different best practice recommendations to kind of prepare you for running Dapr in production.